Your thoughts, your memories, the intricate symphony of your senses processing this very moment. You believe it's real, don't you? A product of a vast ancient universe, billions of years in the making. But what if the very act of thinking, the entire sprawling tapestry of your consciousness, is a cosmic mirage, a fleeting anomaly that just flickered into being, alone in the infinite void? Because the most terrifying, mathematically inescapable truth, lurking in the shadows of physics, screams this: it's statistically far more probable that you are nothing but a single disembodied brain, spontaneously birthed from the vacuum, carrying a complete, vivid, yet utterly false memory of a universe that never truly existed. You look around, a sprawling, intricate tapestry of existence, planets wheeling around suns, suns clustered into galaxies, galaxies woven into a vast, luminous cosmic web, from the perfect spiral of a supernova remnant to the delicate dance of electrons in your very brain. The universe screams order. It's a symphony of precision, a cosmic clockwork, ticking with impossible accuracy. This intricate arrangement feels natural, inevitable, the very bedrock of reality. It has to be this way, right? This is the universe we observe, the one our senses confirm, the one our science meticulously maps. But here's where the cosmic strategist whispers a chilling secret. Everything you perceive, everything you hold dear about the universe's fundamental nature, is screaming a lie, because the cold, hard, unblinking eye of thermodynamics sees this astounding order not as a triumph, but as a statistical crime. You see, the universe, at its most fundamental level, is a slave to a single relentless master, entropy, the second law of thermodynamics. It dictates that disorder, chaos, randomness always increase, always. Think of it like this: if you drop a perfectly ordered deck of cards, they scatter into chaos. They never, ever spontaneously reassemble into perfect suits and numerical order. That's entropy in action. The universe, left to its own devices, should devolve into a featureless, undifferentiated soup, a uniform cosmic sludge where nothing ever happens, where no structure can possibly exist. It should be the ultimate monotonous silence. Yet here we are, a universe teeming with structure, with galaxies that spin, stars that blaze, and brains that ponder their own existence. This is the statistical equivalent of dropping that deck of cards and having them land every single time in perfect, pristine order. It's an outcome so ludicrously improbable that it should shatter your perception of reality. The universe in its current state is an anomaly, a monstrously improbable fluctuation in the vast chaotic ocean of possibilities. Every atom, every star, every coherent thought you've ever had represents a colossal dip in the cosmic entropy pool. It's like finding a perfectly sculpted sandcastle on an infinite beach when all the forces of nature conspire to flatten it. The most probable state for those sand grains is not a majestic castle, but a featureless, scattered expanse. This is the cosmic coin flip that keeps cosmologists awake at night. If the universe must trend towards maximum disorder, then how did it get to this state of breathtaking, intricate order? And what if the very existence of such a complex conscious observer, you, is not evidence of a grand cosmic design, but rather the ultimate statistical fluke, a transient, impossibly improbable bubble of awareness, floating in an otherwise featureless void? This is the haunting question that brings our understanding of reality to its knees. This apparent violation of statistical probability, this cosmic defiance of entropy's iron grip, is the central mystery that gives birth to the most unsettling idea in all of cosmology. Because if the universe is such an improbable event, then something far, far simpler, far less ordered, is statistically more likely to spontaneously manifest. And that, my friends, is where the Boltzmann brain emerges from the darkness. The ghost in the machine, the statistical specter that haunts our cosmic dreams, has a name: Ludwig Boltzmann. This 19th century Austrian physicist was a titan, a relentless mind who dared to describe the universe not as a grand, deterministic clockwork, but as a vast, seething ocean of atoms. He plunged into the heart of thermodynamics, not through abstract equations, but through the brutal, beautiful logic of probability. And in doing so, he accidentally unleashed a monster. Boltzmann's genius lay in connecting entropy, that relentless drive towards disorder, to the sheer number of ways particles can be arranged. A highly ordered state, like that pristine deck of cards, has only one or a few ways to exist. A chaotic, scattered state, billions upon billions of ways. So chaos is simply overwhelmingly more probable. Over infinite time, any possible configuration of particles, no matter how improbable, will eventually occur. But the simpler the configuration, the more probable it is to spontaneously pop into existence. This is the lethal logic that slices through our comfortable reality. Imagine an infinite, truly infinite, empty universe, a boundless expanse of cold, dark vacuum. Over truly staggering timescales, even in this ultimate emptiness, quantum fluctuations will inevitably occur, tiny ripples in the fabric of nothingness. Most of these fluctuations are utterly insignificant, vanishing as quickly as they appear. But occasionally, a truly bizarre fluctuations might spark something, a single atom, a molecule, a tiny fleeting bubble of energy. This is the very essence of statistical mechanics. Now here's the terrifying leap, the one that rips a hole in our understanding of reality. Given infinite time, in that infinite vacuum, what is more likely to spontaneously fluctuate into existence? An entire, vast, intricate universe, teeming with galaxies, stars, planets, and the complex biological machinery that forms a conscious brain, complete with all its memories and scientific understanding. Or a single, isolated, disembodied brain, flickering into existence for a fraction of a second, complete with all the same memories and scientific understanding, but lacking any actual external universe to correspond to those memories. The answer, according to the brutal mathematics of probability, is the isolated brain. Overwhelmingly, think of it like this. To spontaneously create an entire universe, you need to arrange an incomprehensible number of particles in an incomprehensibly precise way, across incomprehensibly vast distances. That's a statistical nightmare, a lottery ticket with more zeros than you can imagine. But to create just a brain, a mere kilogram of matter, even if it's hypercomplex and self-aware, is many, many orders of magnitude simpler. It requires vastly fewer particles, far less energy, and far less ordered arrangement. So, if we assume our universe is old enough, vast enough, and fundamentally governed by the laws of statistical mechanics, then the probability of a Boltzmann brain spontaneously appearing is astronomically higher than the probability of an entire coherent universe like ours appearing, with us in it, perceiving it. Our entire perceived reality, every star, every galaxy, every conversation you've ever had, could be nothing more than the internal, self-consistent hallucination of a brain that popped into existence for an instant, then vanished. A cosmic credit card, maxed out on a single, impossible transaction. This isn't science fiction. This is a direct, horrifying conclusion derived from our most fundamental understanding of physics. It implies that for every genuine, evolved, universe-observing consciousness like yours, there might be billions, trillions, or even an infinite number of these ghost brains flickering in and out of existence, each believing for a fleeting moment that they are experiencing a vast real cosmos. It's the ultimate cosmic confidence trick. And if the universe truly is infinite, or if it undergoes eternal inflation, then the problem explodes. If you're wrestling with this terrifying truth, if the sheer audacity of this idea has punched a hole in your comfortable reality, then you're exactly where we want you. Hit that like button and subscribe to The Cosmic Strategist, because we're just getting started on this journey into the most mind-bending secrets of the cosmos. The Boltzmann brain isn't just a bizarre thought experiment. It's a cosmic cannonball aimed squarely at the heart of modern cosmology. Because if the statistical likelihood of a fleeting disembodied brain with false memories is greater than the probability of an entire coherent universe like ours, then our very existence becomes a lie. Our observations, our scientific models, our entire empirical foundation crumble into an elaborate, self-consistent hallucination. This isn't just an inconvenience, it's an existential crisis that threatens to unravel the entire scientific enterprise. Imagine the horror. Every piece of data we collect, every galaxy we map, every fundamental constant we measure could simply be part of a phantom universe conjured by a lone floating brain. How do you do science when your most basic assumption, that the universe you're observing is real and evolved naturally, is statistically undermined? This is the profound, impossible question that brought cosmology to its knees. Cosmologists naturally recoil from this statistical abyss. They cannot simply shrug and accept that their entire field might be built on a house of cards. So they fight back. The battle against the Boltzmann brain is a desperate intellectual struggle, a cosmic exorcism to banish this statistical demon from our reality. The first line of defense often involves the concept of eternal inflation. This theory, which posits that the universe is not a single, isolated bubble, but rather an infinite, ever-expanding fractal of pocket universes, initially seems to make the problem worse. If there are infinitely many universes, surely there are infinitely many Boltzmann brains, a terrifying proliferation of phantom consciousness. But some physicists argue that eternal inflation might actually provide a strange kind of salvation. The idea is to introduce a measure, a way to weigh the probabilities of different outcomes in an infinite multiverse. This is where the struggle gets truly mind-bending. How do you measure infinity? You can't simply count. Different measures lead to wildly different conclusions about what kinds of universes and what kinds of observers are most likely to exist. One popular approach is the causal patch measure. This method focuses on the number of observations an observer could make within their cosmic horizon over their lifetime. The idea is that more real observers, those who live in long-lived, complex universes, would make vastly more observations than fleeting Boltzmann brains. If you weight the probability by the number of observations possible, then observers in grand evolving universes like ours suddenly become vastly more probable. The causal patch tries to rescue us by saying, in essence, yes, Boltzmann brains exist, but they're so brief and observe so little, they don't count as much. It's a desperate gambit to redefine what likely even means. Another contender is the proper time cutoff. This measure essentially puts an arbitrary limit on how long a universe or an observer can exist. If you cut off the time axis in your infinite multiverse, you can try to artificially limit the number of Boltzmann brains that can form. But this feels like cheating, doesn't it? Imposing an external arbitrary rule on the universe just to make our reality feel more secure. It's like saying the deck of cards can only scatter for 5 seconds, so they can't get too chaotic. The struggle is also waged on the battlefield of quantum gravity. Some theorists propose that the very act of consciousness, or the emergence of complex information, might somehow stabilize the vacuum against these rogue fluctuations, a kind of cosmic self-preservation mechanism. But this pushes us into the realm of truly speculative physics, where the line between science and philosophy blurs. Ultimately, the fight against the Boltzmann brain forces cosmologists to confront the deepest questions about the nature of existence, the meaning of probability in an infinite cosmos, and whether our most elegant theories contain a hidden, self-destructive flaw. This terrifying paradox is not just an academic curiosity. It's the universe holding a mirror up to our understanding, forcing us to ask, are we truly here, or are we just a whisper in the cosmic wind, dreaming of stars? The fight to exorcise the Boltzmann brain from our cosmic reality is a testament to humanity's desperate need for a coherent, stable universe. But the proposed solutions, while mathematically ingenious, often come with their own terrifying caveats, proving that even when we attempt to rebuild reality, we might be building on shifting sands. One of the most radical counterpunches involves rethinking the very nature of vacuum energy. The vacuum, we're told, isn't truly empty. It seethes with quantum fluctuations. It's from this seething that a Boltzmann brain might spontaneously appear. But what if the vacuum itself isn't stable? What if, in an infinite, eternally inflating cosmos, the true vacuum state is one where such spontaneous fluctuations are suppressed, or where their effects are so fleeting they can never coalesce into complex, self-aware structures? This introduces the concept of false vacuums. and true vacuums, where our universe might be trapped in a metastable state, a temporary bubble that prevents the proliferation of rogue brains. But this begs the question, how did our vacuum get so lucky? And what happens when it eventually decays to the true vacuum? The cure might be as terrifying as the disease. Another desperate attempt to defend our reality hinges on the idea of anthropic principle refined. Not just that the universe is fine-tuned for life, but that it's specifically fine-tuned to prevent the overwhelming dominance of Boltzmann brains. This sounds suspiciously like special pleading. It implies that the universe must conform to our expectations of what a real universe should be, rather than simply letting the chips fall where they may according to the cold, hard logic of probability. It's a philosophical retreat disguised as a scientific argument, trying to force the universe to behave simply because we exist. Some cosmologists propose that the issue lies not with Boltzmann, but with our understanding of time itself. If time isn't truly infinite, or if it has a beginning and an end in a way that limits the possible number of fluctuations, then the statistical argument for Boltzmann brains might be undermined. But this requires radical revisions to our most fundamental theories of cosmology, pushing us into uncharted territory where the very concept of space-time might be fundamentally different from what Einstein envisioned. It's like rewriting the rules of the game mid-play, just because we don't like the score. Perhaps the most unsettling solution is the cosmic measure problem itself. If there's no unique, universally agreed upon way to compare the infinite probabilities within a multiverse, then the entire paradox might simply be a symptom of our own incomplete understanding of infinity. It's a philosophical quagmire. If you can't define what's probable in an infinite landscape, then the paradox of the Boltzmann brain might simply be an artifact of our mathematical tools rather than a fundamental flaw in reality. But this doesn't make the brain any less terrifying. It just means we lack the language to properly confront it. The very concept of a multiverse, initially proposed to explain away the fine-tuning of our universe, ironically amplifies the Boltzmann brain problem. If there are infinitely many universes, then every conceivable outcome, no matter how improbable, must occur an infinite number of times. The multiverse, while solving some problems, opens the door to an infinite parade of phantom observers. It's a cosmic hydra. Cut off one head and two more, equally terrifying, grow in its place. Ultimately, the struggle against the Boltzmann brain is a profound exploration of the limits of our knowledge. It forces us to ask, are our current physical laws truly complete? Is there some hidden mechanism, some unknown force that actively suppresses the spontaneous generation of conscious minds in the vacuum? Or is the universe far stranger, far more statistically counterintuitive than we ever dared to imagine? The solutions proposed so far are not clean, definitive victories. They are philosophical compromises, desperate attempts to patch the holes in our understanding, all while knowing that the cosmic strategist, Ludwig Boltzmann, might still be right. The universe might just be a dream. Our journey through the Boltzmann brain paradox has dragged us to the very precipice of reality, forcing us to confront the chilling possibility that our intricate universe, our very consciousness, might be a statistical ghost. We've wrestled with the relentless march of entropy, the brutal logic of probability, and the desperate intellectual struggle to defend our perceived reality against the ultimate statistical intruder. The cosmic strategist Boltzmann stares back from across the centuries, his equations whispering a terrifying truth. It's easier to conjure a mind than a cosmos. This isn't just an abstract academic debate. It's a profound existential gauntlet thrown down by the universe itself. It forces us to acknowledge the incredible fragility of our perceived reality, to question the very foundations of what we call real. If the most probable outcome is a fleeting, disembodied brain, then our intricate existence, our shared perceptions, become an almost miraculous defiance of cosmic odds. This makes our conscious awareness, our ability to observe, to question, to simply be, an even more astonishing, improbable gift. The Boltzmann brain paradox, in its terrifying brilliance, illuminates the deep, unsettling connection between the most fundamental laws of physics and the very nature of consciousness. It reminds us that the universe is not obligated to conform to our comfortable narratives. It is vast and different, and governed by rules that can twist our common sense into knots. Yet, in this very confrontation, in this intellectual struggle against cosmic absurdity, we find a deeper appreciation for the mystery of existence itself. We push the boundaries of knowledge, not just to understand the cosmos, but to understand what it means to be in it. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.